All right, a smarter person may have tried this problem before putting it on. Or maybe it makes me smart that I refuse to try them ahead of time because I'm cocky and therefore I think I can do it. It'll be fine. We'll get through it. I'm excited because I see a composition of functions, which means chain rule is going to come into play. I'm very excited. I also have a graph, which really brings me some joy. We'll see if I get myself stuck here. We are trying to find the composition of a function where our function is definitely continuous, right? No breaks in this function. We discussed composition of a continuous function with a continuous function, still continuous. We might have some worries about the overall domain that when we plug in from 0 to 10, but here's my concern because we don't have something that has every value available. I would want to make sure that as long as I'm on 0 to 10, the output I'm going to get is still within 0 to 10, and that's okay. It goes from -2 to 6. So -3 to 10, -2 to 6 is a subset. So anything I land on in my inside function of h of x is still going to be available as an input for h of x again. So that's me being a little bit pedantic, but like I wanted to verify we weren't in trouble because we didn't have that negative infinity to infinity we typically been looking at where we didn't have to worry about that domain restriction impacting the inside function and then impacting the outside function. Anyways, we want to find, of course, the absolute minimum value for f on this range. Oh, on the range of 0 to 10. Cute, cute. That's why we needed to go further than 0 to 10 because our outputs involve negatives. This is going to be fun. I'm excited. I might screw it up, but it's good. We know we need critical values. We got to do some candidates, maybe not a whole candidate test, but let's go ahead. F prime of x, come on, you can write. Derivative of the outside function, leave the inside the same, times the derivative of the inside function. All right, for critical values, we would look for when this is undefined, not going to happen for this beautiful guy, or when it's equal to 0. So I want to know when this thing is equal to 0, which is another zero factor property, right? When is my h prime of x equal? Oh, I'm expanding. I'm going back on my word. This is what happens if you don't try a problem ahead of time. We need 0 or undefined for this particular case because we're talking about h prime, which is the slope, right, of our line. And we're not looking for our zeros on this graph. We're looking for when our slope is undefined. And we can see here, this slope is undefined, right, at all of these corners. Those are when our derivative would break. We'd have some problems with our derivative. So for this section, for the h prime of x equal to 0, we're looking at the following values. When x is equal to 0, when x is equal to 4, and when x is equal to 6. All of those are times my h prime is equal to 0. Now, oh no, I'm deeply regretting my life choices of not trying this one before. Because now I need h prime of h of x to be undefined or 0. I now know undefined is going to be my issue after all my babbling. So h prime of h of x is undefined when the input is equal to those things, right? So before it was just x is equal to. Now it is h of x. Oh no, this is going to be horrible. Is 0 or 4 or 6. But of course, this is telling me y values. I'm just like covering my mouth in shock and horror at just how gnarly this problem is. But I'm still in love with it. We need to know when the output of my h function is 0, 4, or 6. So let's just do this thing. 0, oh my god. We're gonna plug everything in. This is insanity. But okay, that would give me out 3, 5, and 8 as possible x's. Because if, let's just plug this in so we can understand what things happened in my brain here. If we were trying to find h prime of h of 3, we would have to deal with the inside piece first, right? And h of 3 is 0. So we'd be doing h prime of 0. And well, h prime of 0 is undefined because that's the slope at that point, Okay, so that's what I'm doing. I'm finding the things that when plugged in would give us out y's that would make the x. I'm so sorry. I'm so sorry. All right, so let's do another one. Let's do 4. So 4 is a little bit easier. We only get 4 one time, thank goodness. That happens when x is equal to 1. All right, again, if we want to think about what this is telling us, of 1, this is h prime of, that's 4, and h prime of 4 is one of those spots where it's undefined. That's all we're doing. That's it. I don't like how that looks, so I'll fix it. Cool. All right, and last one is 6. We only hit 6 once, and it's at 0, which we already have. So I'm not even going to bother. Okay. So we have a lot of candidates. Way, way, way too many candidates. But it's fine. Oh, this is so dumb. Oh my God. Well, this is going to show us how silly this was. And then we're going to be like, Kelly, you dummy. Okay, so 0, 1, 3, 4, 5, 6, 8, and 10. Let's just highlight where these all came from. 0, 4, and 6 were candidates from that factor of the little tail of the chain rule. 3, 5, and 8 all came from when my h of x was 0, which gave me out this bit here at the top. 1 was from when h of x was equal to 4. And 10 was an endpoint. Technically, 10 was an endpoint, and so was 0. We also had that duplicate of 6 also. If we really want to think about it, 6 also gave us this. So we had like a bunch of different times that we kept hitting that 0. We got 0 as a candidate 3 different ways, but it's fine. This is when we start feeling silly because we go, okay, let's go plug these in. And we go, okay, we have a graph. 0 is 6, 1 is 4, 3 is 0, 4 is -2, 5 is 0, 6 is 2, 8 is 0. And then we go, what nonsense did I just do? I have the graph. Oh, I have the graph of f of x. Okay, good. There isn't nonsense. Y'all, I need to do one more step. I got excited. I was like, this is stupid. I could have just looked at the graph. But no, I need h of x. So gross. So now h of 6 is 2. H of 4 is -2. H of 0 is 6, 6, 6. -2 is 5 and some change. I refuse to figure out what that is. 5.33. 5.33. And when I plug in 2, it's 2. Oh my God. I almost lost my mind here. We need the absolute minimum, so we care about this. This problem. Truly horrible. Truly horrible. There's probably a smarter way to do it. It has to have been, right? Let's just think about it. Because you know me, I'm like a dog with a bone. And if you're still listening to this, you are equally bananas. So we've got absolute minimum. F of x is h of x with an h of x inside of it. So we know the absolute minimum happens here or here, right? The absolute minimum has to be -2. That's the smallest this can be. So -2 gives me out. We know h of x when it's the absolute minimum is equal to -2, which means, not doing all that other work, h of x is equal to either 4 or 10. When is h of x equal to 10? This never happens. When is it 4? It's 4 at -1. +1. My God, I can't read a graph right now because I've lost my mind. So that was a much easier way to handle this problem. Was instead of doing the candidates test to just like think for a second. 100%. Though the candidates test is what we're supposed to do, so we can use the chain rule and all that. But I'm not about doing what I'm supposed to do. I'm about figuring out if there was a smarter way to do it. But yeah, looking at this graph, we could see the minimum value. This is a composition. Its minimum is still going to be -2 unless for some reason neither of those values were on the domain. Then we might have gotten in trouble. So I guess there's a usefulness to the candidates test. I don't know. I talked too long, and I'm sorry.